Okay, now for the rest of the functional groups. Remember that we could have started with ethers, but I'm not going to ask you to name those, so you don't need to worry about it. Okay, next comes amines, and it kind of is funny to me that the word amine sounds like it's mean, and if you consider like an N like that is sort of like a mean face. I don't know if you all think that that's a mean face or not, but that would be what an amine is kind of showing you, is that you have a nitrogen involved in something. Now, it can be more than just an NH2, but that's sort of the most basic form of things. So just like with alcohols, these need to be numbered, and you need to count the number of carbons and then tell where that amine group is coming off of. So here we go. We've got 1, 2, 3, 4 carbons here. And so that's a butane. We take off the E and end that with amine. So this becomes butanamine. Butanamine, and that's all one word. Now, since this is at the first position, just like with other examples, you do not need to number it. You could have an NH2 or a nitrogen located in different areas of that chain as well. So in this case, we have a longer chain. There are 1, 2, 3, 4, 5, 6 carbons there. And to get to the lowest possible number for nitrogen, we would number from right to left. So that would be 1, 2, 3. So this becomes, we've got hexane, since there's 6 carbons. We take off the E and put amine. And then we have to tell people that it's number 3. So this is 3-hexanamine. Okay, those can get much more complex, but we're going to kind of just stop right there. Okay, next we have carboxylic acids. Now, sometimes these are represented in different ways. Actually, all 3 of these would be the exact same compound. So let me explain that. You've got a carbon right here as part of the functional group that's attached to 2 oxygens and a hydrogen. There's a double bond to the first oxygen, and then we've got a single bond to the OH. So that makes a COOH, which is exactly what you see right here, COOH. Or we can sort of combine like terms and end up with CO2H. In any of these representations, the carbon that's involved in the carboxylic acid is carbon number 1 by definition. That's going to be 1. Then we've got 2, 3, and 4. So you can see that written out in this manner, there's still 4 carbons, and written out in this manner, there's still 4 carbons. So in all of those cases, you would start with a root word of butane, and then we would take off the E and replace it with oic acid. So it becomes butanoic, and then a separate word is acid. Okay, so those are all butanoic acid. If you had 5 carbons, it'd be pentanoic acid. 6 would be hexanoic acid. Where I see the most issues with this, it's real easy to forget to count the carbon that is involved in the COOH. So don't forget to count that. It still exists. It's important. Okay. Sorry, let me scroll this up. Next, we have aldehydes. So aldehydes, remember, those have a CO at the end of the chain. And these can be represented in different ways too. I'm not trying to confuse you, but it's just the way that they can be represented. So we have a carbon right here. It's connected to a chain. in this direction right there, right? That's connected to the rest of the chain. We have a C-double-O bond right here, and then there's a hydrogen in that direction. I'll take that away so you can see all that stuff. But we don't have to always write that hydrogen. Many times it's not written. So sometimes it can just be that. Or sometimes you even see it like written like this, with just CHO. Again, all of these have 4 carbons, and we count all 4 of them when we're naming. 1, 2, 3, 4. 1, 2, 3, 4. This is 1, 2, 3, 4. All of those start with butane. So butane is our major chain name. Then we're going to replace the E with AL. So this is butanal. Now, I'm overpronouncing that for a reason. If you remember, alcohols are end with OL, so that would be butanol. So I overpronounced the A so that we know what we're talking about, butanal. And that's just 4 carbons, and the end of that chain has a C-double-O bond. We don't have to tell people that the C-double-O bond is at the end, because by definition, aldehydes have a C-double-O bond at the end. Okay, so we don't have to worry about that too much. On the other hand, ketones have a C-double-O bond that's not at the end. So ketones have a C-double-O bond somewhere in the chain, and that means that we have to tell people where they are, okay? Unless it's in a ring. So here we have a C-double-O bond right there. Sorry for the beeping. We've got 1, 2, 3, 4, 5 carbons right there. So that would be pentane. Now, with ketones, we take off the E and we end with O-N-E, own. So that would be O-N-E. Pentanone. And we have to define where that C-double-O bond is, and the lowest number that we can get there is number 2. And that would be good. Now, in a vast majority of ketones, you need to tell people where that C-double-O bond is. It should not be a 1 because that's aldehydes. In a ring, sometimes you can get away with not doing that, like this. Why? Because there is no end, but if you change the end of the word, that's considered to be number 1. Oh, and this is a problem. I knew there was an issue somewhere in here. I hope that you spotted that. That ring should be cyclopentane. And then we would take off the E and put "-one" at the end. So that originally said hexane. So it would be cyclopentanone. And the hex was a mistake there. Okay. Finally, we have amides. So just like with carboxylic acids, the end of the chain, which it actually doesn't have to just be on the end of the chain, it's at 1 carbon position, you have a C double bond, oxygen, and a bond to nitrogen. So it's a C-O-N, all on the same carbon. And the carbon that is right there is going to be carbon number 1. So 1, 2, 3, 4 carbons right there. That makes this butanamide. So I can count that from either direction, 1, 2, 3, 4. I'm sorry I didn't tell you where I got that from. It would be butane. We take off the E, and I just realized that it may not say that very clearly in the top there. But we take off the E and we add the term amide. So this becomes butanamide. Remove E and replace with amide. Okay, and that's it. You did a great job. Now I would love for you to go and look at the back of different bottles and see if there's any of those terms that you can recognize out there. I bet you'll find a few. Thank you very much.